Morning, students. Today we'll discuss total pressure and the term related with fluid pressure and its measurements. So, first of all, we'll know what is fluid total pressure. Total pressure on an immersed surface is the total force exerted by a static fluid on a surface, either plane or curved, is the shape of the surface, and when the fluid comes in contact with the surface. Okay, the position of an immersed surface may be horizontal, vertical, or inclined. So the total pressure on an immersed surface, it is a force exerted by a static fluid. That means the fluid at rest on the surface, which can be either plane or curved, and when the fluid comes in contact with the surface. When a body or an object is immersed in a liquid or a fluid, we generally, okay, now we are discussing liquids. So when a body is immersed in a liquid, that liquid will exert a force on the surface of the object. Okay, that is called total pressure, and the position of the immersed surface can be horizontal, vertical, or inclined. So we have to uh, find out the equation for calculating the total pressure by considering in which position the object is immersed. Okay, so next term is center of pressure. Center of pressure is the point of application of total pressure on the surface of the body. A center of pressure means you have heard about center of gravity and all. Like this, center of pressure, it is the point of application of total pressure on the surface of the body. Okay, now we will discuss the line of action of this force and how we derive the equation for finding out the total pressure. Okay, first we shall go through the line of action. This is the line of action of the resultant hydrostatic force. It is hydrostatic force means again the fluid at rest, okay, the liquid at rest, exerting force on the object immersed in it. Okay, the line of action of the resultant hydrostatic force in general does not pass through the centroid of the surface. It goes below or it lies underneath where the pressure is high. What is that centroid of the surface? Centroid of the surface means it is the center of the geometrical shape of the object. Okay, so this line of action of the hydrostatic force, that is certain hydrostatic force, does not pass through the centroid and it goes below or it lies underneath where the pressure is higher. Now how we derive the equation? Using this principle, that is two parallel force systems are equivalent if they have the same magnitude and the same moment about any point. Okay, two parallel force systems are said to be equivalent if they have, provided they have the same magnitude and the same moment about any point. It should have the same magnitude and same moment about any point. Then how we derive it? Equating the moment of resultant. The resultant force moment is equated to the moment of distributed pressure force above the axis. Okay, it is about the x-axis, we are equating it. The moment of resultant force is equated to the moment of distributed pressure force. So when we derive the equation, we'll get an idea, we'll get more idea about it. Okay, next the derivation. First we have to look at the diagram. An image is given, an object which is immersed vertically in the liquid. Okay, so consider a vertical surface of arbitrary shape is immersed in an arbitrary shape. It is not regular shape. An object is immersed in that. So how we take it? First of all, we have to consider a small strip from the body or surface immersed. Okay, that strip will be having a width b and thickness dh. Strip, you can see in the diagram, it is hatched portion that is having width b and thickness dh. So what will be the area? Because it is shown in rectangular portion, so area will be width b into dh. Okay, now let A is the total area of the surface that is measured in square meter. That means width b is in meters and dh in meters. Okay, thickness dh in meters. So h bar, it is shown in the diagram. H bar is the distance of center of gravity of the area from the free surface of liquid. The area from the center of gravity is denoted by the letter G, and its distance from the free surface is given as h bar. It is shown in the diagram. H bar is the distance of the center of gravity of the surface from the free surface of liquid. Okay, center of gravity of the area from the free surface of liquid, that is h bar. It is also measured in meter. G is the center of gravity of the plane surface. The surface means the object that is immersed in the liquid. Okay, so G is the center of gravity and h bar is the distance from the free surface of liquid to the center of gravity of the area. And now C is the center of pressure. As I mentioned earlier, C is the center of pressure is the point where the total pressure acts on the surface. And C bar is the distance of center of pressure from the free surface of liquid. It is also shown in figure. C bar is the distance from the free surface of liquid to the center of pressure. That is also measured in meter. We know that intensity of pressure intensity is equal to rho GH. Rho GH, P is equal to rho GH. And it is first we calculate the pressure on the strip. That is P is equal to GH. H is the distance of the strip from the free surface of the liquid. Okay, from the free surface distance is H. So the pressure intensity will be rho GH. The area of the strip is given as dA because it is a small strip. dA is equal to B into dH, width into height, B into dH. So total pressure force on the strip, you have to make it clear that it is not the pressure, it is the pressure force we are finding out. But the force and pressure are different. Pressure is force by area. Here we are finding out the force on strip. That you have to bear in mind. Very important. We are calculating the total pressure force. Even though term is known as total pressure, but we are calculating total pressure force on the strip. That is dP. Okay. dP is equal to intensity of pressure on strip into area, because pressure is equal to force by area, then naturally force will be pressure into, here it is given as pressure into area of strip, that is rho GH into B into dH. Okay, integrate. Now it is we got the pressure of the strip, pressure on the strip. Now we have to calculate the pressure on the entire surface. Okay, then we need to integrate the above equation. The total pressure on the surface can be calculated by integrating the above equation. That means total pressure on the whole surface, capital P is equal to integral dP, that is integral rho GH into B into dH. Sorry, that is equal to rho G is a constant. Now rho will not change for the same liquid, and G is acceleration to gravity, into integral H into B into dH. But we know that B into dH is dA. That is already given in the above equation. So substituting dA in place of B into dH, we get P is equal to rho G into integral H into dA. But integral H into dA is moment of surface area about the free surface of liquid. You have learned it in your college, or plus 1 or plus 2, or in high schools you have learned about this moment of force. Here the moment of surface area about the free surface of liquid is equal to integral H into dA. That is equal to area of surface into distance of center of gravity from the free surface. Moment of surface area about the free surface of liquid is equal to, that is the area of surface, because when we want to find the moment of surface area, we have to multiply the area by the distance from which the force acts. Okay, the area of surface into distance of center of gravity from the free surface. We know that area of the surface is small a, and distance from center of gravity is center of gravity from the free surface is h bar. So A into h bar. Substituting the values of h bar in the place of integral H into dA, we will get total pressure force P is equal to, it is total pressure force. Okay, we have to keep in mind it is pressure force. P is equal to rho G into integral H into dA is A into h bar, because okay, integral H into dA is equal to A into h bar, because area of surface and distance of center of gravity is that is A h bar. So rho G h bar, but we know that rho G is equal to W. W is the specific weight of the liquid. So P is equal to rho G h bar, or it is equal to W A h bar, where W is the specific weight of liquid measured in Newton per cubic meter. Of the, if the value of P is kilogram per square meter and G in 9.81 meter per square second, then SI unit of total pressure force will be Newton. Here, why the unit comes in Newton? Because it is the force, not the pressure. That is a very important part, you have to remember it. Okay. Now we will move on to the next one, that is total pressure on a horizontally immersed surface. Earlier we discussed about the object immersed vertically. Now we will check what is the equation for horizontally immersed surface. Here also same thing, consider a plane horizontal surface immersed in a static fluid. It may be noted that pressure intensity at every point is same on the entire surface, because the center of gravity and all the points on the surface may be at equidistant from the free surface. So there won't be any difference between H and H bar. So pressure intensity at every point is equal to P is equal to rho GH. Total pressure force is equal to P into area, that is rho GH into A, where A is the total area of the surface measured in square meter. And as I said, all the points are at equidistant from the free surface, h is equal to h bar. So the equation becomes rho g h bar, where h bar is the depth of center of gravity from the free surface of liquid. Here all the points are, including the center of gravity, are at equal distance from the free surface of the liquid. So hence h becomes h bar. The equation is rho g h bar, or it can be w h bar, where w is the specific weight of fluid measured in Newton per cubic meter.